Hey guys, Mr. Is to help you out on the next section. So in section 5.8, we're going to be multiplying radical expressions or multiplying complex expressions. So we're definitely going to take our time with this. This is going to be something new for you guys in Algebra 2, but hopefully it's not going to be too bad. We're actually going to start out with one of the tougher examples here, and if you can handle this, should be all right afterwards. Okay, so when it comes to multiplying radical expressions, we got 2 cube root of 42x cubed times 5 cube root of 147x to the fourth. What we're going to do is first multiply the coefficients. So those are the numbers in front. Okay, so 2 times 5 is 10. And then what we're going to do is multiply the what's called the radicands, the things inside of the radicals. So we're going to multiply the 42 times the 147. Holy cow, let's see what that is. 42 times 147 is 6,174. I'm sure everybody knew that. And then x cubed, x to the fourth is x to the seventh. Okay, so that's the first thing that we do. We multiply the number outside, leave it outside. We multiply the numbers inside, leave them inside. And then what we're going to do is, very simple term, but we're going to simplify. We're going to break it down. All right, so we're starting with cube root here. Remember, with the cube root, you need to break it down and try to find pairs of threes. All right, so what two numbers multiplied together? Well, kind of easy. We just did 42 times 147. So I'm going to keep those there. All right, so 42 is 2 and 21. 21 is 3 and 7. Okay, 147. I think that is 3 and 49. And then 49 is 7 and 7. Right, I'm going to just double check that. 147 divided by 3. Yep, 3, 4. Okay, so cube root, we need to have 3 of them. All right, we got a 2. We got a 3. Okay, all righty. So the only thing we have 3 of is a 7. So that means I didn't mean to cross that up, but a 7 gets to go outside with the 10. And then let's look at here with, and then inside, I'm going to leave some space because we have the x's. Inside of the cube root, we'd have a 2, a 3, and another 3. So 2 times 3 is 6. 6 times 3 is 18. All right, now with the x's here, we have x to the 7th. All right, how many groups of 3 would we have? We would have 2 of them with 1 left over. So there's the final expression, 70x squared times the cube root of 18x. That was a tough problem. So if you kind of got that, kind of feel good about yourself. Okay, so let's keep this going here. Let's do this. We're going to put some adding and subtracting as well involved here before we move on to complex numbers. All right, so let's see here. We got a cube root of 42 times a negative 3 times the cube root of 36. So let's multiply the outside numbers. Now, technically, there's a number 1 out here. So 1 times negative 3 is negative 3. And then we got a cube root of, all right, we got a big number here, 42 times 36. 1512, 1,512. All right, so then we simplify, we break it down. Okay, that is 42 and 36. All right, I know 36 is 6 and 6, 2 and 3, 2 and 3. All right, 42 is 2 and 21, 3 and 7. All right, we need 3 of them to break out a big cube root. All right, 1, 2, 3. All right, we got 3 2s. We can break 1 out. And then we have 3 3s. We can break 1 out. And then we'd have a 7 left over. All right, so the negative 3 is going to be multiplied by 2, which is 6. Negative 6 and times it by 3. Okay, so that's a negative 18. And left over inside is just the 7. Okay. Let's check this next one out. All right, so here we have to distribute. So we're going to multiply the 6 radical 6 times the 21 and take the 6 radical 6 and times the radical 10. Technically, remember, there's 1s outside of both of these. So 6 times 1 is 6. And then 6 times 21. I'm just going to use the calculator because it's early in the morning and it's Monday. I don't feel like doing math here. All right. Radical 26 or 126. All right, now 6 times 1 is 6. And then 6 times 10 and the side of the radicals would be 60. All right, we're going to break them down, see if anything happens here. All righty. Well, that's 6 and 21. It's 2 and 3. 3 and 7. All right, so a square root, we only need to have 2 of them. So we got a pair of 3s. That goes outside. The 2 and the 7 stay inside. So 3 times the 6 is 18. 2 and the 7 makes 14. All right, now 60 here. I know 6 and 10. It's 2 and 3. And then we got 2 and 5. We look for partners here. We got a pair of 2s. The 2 can go outside with the 6. It's 12. And the 3 and the 5 multiply inside. So this is, even though it's not the nicest looking answer here, would be okay. Next here, we got 1 minus radical 5 times 1 plus radical 5. These are actually a special property called a conjugate. But let's go through what happens here. All right, we got to distribute the 1 to both of those. Okay, well, 1 times 1 is 1. 1 times radical 5 is 1 radical 5. Okay, then we got to distribute the negative radical 5. All right, negative radical 5 times 1 is negative 1 radical 5. And then negative radical 5 times negative radical 5 is a negative radical 25. All right, we're going to try to simplify them. Obviously, we can't simplify 1. Radical 5 doesn't break down at all. It's just 1 and 5. Nothing breaks out. Same thing here. We can't break down 25 to 5 times 5. We have a pair of 5s. So I'm just going to rewrite this first part here because nothing breaks down. So minus radical 25 is the same thing as just minus 5, right? Because you guys think about it here. Take a step back. What's the square root of 25? The square root of 25 is 5. All right, now we're going to combine like terms. We can actually combine these two together because they are both radicals. 1 radical 5 minus 1 radical 5 actually cancels it out. And all we can do is combine the 1 and the minus 5. Those are both real numbers. 1 minus 5 is negative 4, and that's it. So all that work together can happen where everything cancels out, and you're just left with a simple expression. Okay, the second thing we're going to look at here is complex numbers, so things that have i's. So if we have i's, we're going to distribute like we would do. Okay, 2 times 8, 16. 2 times negative 7i, negative 14i. All right, we're going to go through, multiply 3i times 8. 3 times 8 is 24. We got an I. 3i times negative 7i is a negative 21i squared. We just need to remember here, after we combine the middle terms, that I squared is equal to negative 1. So we're going to change that I squared to a negative 1. Means we then can combine that 21 and the 16 together to get a number in front. All right, so let's go through. Let's distribute this here. Combine these like terms. All right, 5 times negative 8 is negative 40. And then 5 times 5i is 25i. Moving on to the next one here, negative 3i times negative 8 is a positive 24i. And negative 3i times 5i is a negative 15i squared. Okay, so we're going to combine the middle terms together. We got negative 40, 25, and 24 makes a 49i. And then we got our negative 15i squared. Then let's change our I squared to negative 1. So this is negative 40 plus 49i minus 15 times negative 1. Now, if you want to do this next step all in one term, you can. The negative 15 times the negative 1 makes it a positive 15. So the last thing we can do here is we can combine the negative 40 and the 15 together. Put those numbers first because they're not imaginary. This is where we can have imaginary times imaginary becomes real. That's the whole purpose behind imaginary numbers. They can become real later on. All right, so negative 40 times 15, or negative 40 plus 15 is a negative 25. And we got 49i. All right, if you guys want to pause this video to try it on your own, feel free to do that. See how this goes. All right, 5 times negative 3 is negative 15. 5 times negative 7 is a negative 35, and we have an I. Moving on to the bottom here, 5 times negative 3 is a negative 15. We got an I, and 5 times negative 7 is a negative 35, I squared. Okay, let's combine the middle terms here. We got negative 15 minus, all right, negative 35 and a negative 15 makes a negative 50i minus 35i squared. Then let's change this here. All right, I squared equals negative 1. So really, all we're going to do is just change this negative 35 times negative 1, make it a positive 35. Ooh, I almost forgot the I there. So the last step, we combine this 35 and the negative 15 together. Negative 15 plus 35 is a positive 20 minus 50i. There we go. Okay, so definitely want to take our time practicing these here, especially I think with the radicals. Those are the ones that usually take the most time. I think the complex numbers here are actually a little bit easier in my opinion. All right, if you guys have any questions, make sure you ask. Take your time on the IXL, and then good luck. I think you guys got this. Thanks for watching. Have a good one.